Hello and welcome back to the channel. If you saw my last video related to data types and variables, you now have the basic foundational idea on how data are stored or used in Python. Next, I'm going to talk about another important topic, operators in Python programming. Operators are important because they allow us to further manipulate data values. We will briefly talk about various types of operators in Python and then dive into arithmetic, bitwise, and assignment operators with simple mathematical examples. A couple of notes before we begin. This video will be more productive if you try the operation statements that I'm going to show you here yourself. So I encourage you to code alongside me and even go beyond what is covered here. Please feel free to pause and play the video as many times as you need. Also, making contents like this video takes a good amount of time and effort. So if you like these contents, please like, share, and add your comments below to show your support. If you want to get timely notifications of new contents or tutorials, please subscribe and hit that bell button. So let's get started. Operators Operators are special symbols in Python and carry out arithmetic or logical computation. They are basically used to perform operations on variables and values of various data types. If we consider the expression 5 plus 3 equals 8, this is how we are normally used to seeing simple additions being done. We just do it a little differently in Python, but it is super easy to understand. For the sake of understanding the concept, in this example, 5 and 3 are called operands, and the plus sign and the equal sign are called operators. Just like there are various data types in Python, and different types can do different things, there are also various operators in Python, and different operators can do different things. Python supports the following types of operators: arithmetic operators for simple addition, subtraction, multiplications, division, and other operations. Assignment operators. There are also comparison operators or relational operators that compare two different values, whether they are equal to or not equal to, greater than, less than, sort of things. There are also logical operators, and, or, and not, that compare or do operation between two different strings or values. There are identity operators, whether something belongs to or whether something is or is not some certain value that we pass. There are also membership operators to check whether something is in or not in, for example, a list. And lastly, there are bitwise operators that perform operation bit by bit at a binary level. In this video, we will discuss the arithmetic operators, bitwise operators, and assignment operators with some example codes. I will make a separate video to show how comparison, logical, identity, and membership operators are used with more practical examples. So let's jump over to PyCharm and first learn about arithmetic operators. Let's start with something that we have already known with a little bit of twist. So all I'm going to do is print 10 by 7 and then run this. And what is happening here is we are passing two different values. And when we put them in under print statement saying we want 10 by 7 to be printed, it actually calculates the result of 10 divided by 7 and gives us the output 1.428. It's basically a floating number with a decimal value because it's not exactly divisible by 7. But what we're doing here is passing values rather than arguments. And often when you write Python codes, we more often tend to pass variables rather than values themselves. So what I want to do is um, assign variables with different values or different types of values, something like this. Here I have A, B, C, and A, B, C, D, and E are my variables. Both A and B are integer values. C is a floating point number, and D and E are string data types. So with these variables, I can do multiple things. Um, so let's say if I want to do something simple in arithmetic, I want to say A plus B, and I want to get that result assigned to variable Y. And this is how we do addition or use addition or operator. And this is assignment operator, which we will come back later to. But for now, we have a value assigned with this statement. We have a value assigned to the variable y, and if you want to print y, and also it might be interesting to sometimes find what is the data type of this y. So we say print type y. Print type y, and let's run this again and see what we get. So here we are using a and b, which are 4 and 2. And since we are adding a plus b and assigning that to y, y would get the value of 6. If we are printing y, we would get 6. If we are printing type of y, we are getting integers because basically we are adding two different integer values. We could we could simply modify this statement and say, let's say we want to add, instead of a plus b, we want to add c, which is a floating point number, and then see what we get as output. When we run this, we still get 6, but we get a floating value because one of the input that we provided was a floating number. So instead of the 6, which is an integer, we get a floating value, which is 6.0 in this case. So let's go one further and say what we would get with some when we add integer plus a string data type. Let's say D, which is a string that says understanding. So here we are doing we're trying to add two different data types, integer and a string. And if we run that, we would get an error saying type error. It would clearly say integer and strings are unsupported with the addition operator. So now next I want to show is, instead of two different data types, let's say we want to add two different strings, D and E. And when we run this, since we have understanding as a string on D and then text concatenation as a text string under variable E, when we do D plus E, it would just concatenate the two strings and print out one long string with both D and E together. And this would be obviously string data type. So far, we have only been doing addition operations. So let's go back to the old a and b variables, but instead of plus, I want to go negative or a minus b and see what happens. So 4 minus 2, I would get 2. 4 minus floating point 2, which is c. In this case, I would get a 2.0, same result, but this would be under floating class type rather than an integer type. Another operator is product. So instead of c, let's go back to integer or a times b. It would give us 8. A divided by b, it would give us 2.0. And that is a floating number. So this is interesting. When we do, these are a and b, both are integers. And when we did product a times b, we saw that we got integer as a output variable or data type. But when we do division of both integer values, the output is a floating number, which is the same as when we say a divided by c. That would also still give us 2.0 floating value. Now let's make it a bit more complicated, and instead of working with two different variables, I would say I would work with a plus b or small b minus c. It's just simple, it's still simple math, and because we have c, which is a floating point number, the output would also be a floating value. I could not necessarily involve all variables. I can combine them with random integer number, and I would still get some output without any issues. If I go back to replacing c with 7, I would end up with an integer number here. It's also helpful to understand that Python honors the standard convention of or hierarchy of different arithmetic operations. So, for example, if we want to do a plus b divided by c um, and run this, we would get 5.0, and that's because division takes priority over the addition, and b divided by c is 2 divided by 2 basically, which is 1, and we want to add 4 to that 1 and end up getting 5.0 because we have a floating value. So the output by default would also be a floating value type. Um, it's also the same as if we are writing this inside a bracket. If we run this, we would still get the same output of 5.0 and a class floating type. But that's not the same as saying, for example, let's say I want to put my bracket around this first, which means I want a plus b to be calculated first and then divide the result by 2.0. So in this case, I would get 4 plus 2, 6 divided by 2, and the result would be 3.0, which also is a floating value. We have to keep in mind that when we do division operations, we cannot use 0 on our numerator, and it doesn't really matter what is or on the denominator. I'm sorry, it doesn't really matter what's on the top. If our when we do division, if our denominator is 0, we would end up with zero division error type. And it will spit out a message saying we cannot divide by 0. I also want to show exponents before I move on to another operators. So for that, I want to go to even simpler numbers. I can get rid of that C because for this one, probably don't need it, as well as the string. So, and how we do exponential calculation in Python is we do double times sign. So a times b, that basically means a to the power of b, and when we run this, we get 3 to the power of 2, which is 9. We can swap around the variables and see what we get. In this case, we get 2 times 2 to the power of 3, which is 8. We can make this even more complicated with another exponential on top of this and run this to see what we get. Oh, in this case, we get an error because we have C undefined. So let's uncomment this and run it again. And we get 512 with a floating type variable. Often in programming or mathematical operations, we are usually interested in finding a square of any number. So how we do that is very simple in Python. We just do b times or b. Basically, this means square of b. B is b to the power of b. And since b is 2, we get square of 2, which is 4. Um, if we are trying to find the square of any other number, let's say 7 to the power 2, we would get 49. Next thing I want to show you is the modulo and floor division arithmetic operation or operators and how we use them. So let's go. So for this, I want to play around with different variables for or different values for the variables. So let's say I want to get rid of all of that, and if I say a equals 10 and b equals 7, because 10 is not exactly divisible by 7, we would end up with some remainder. And when we do a division here, we get 1.42857. If you look at this output, 124587, 124587, 124587, it keeps on repeating. So that's why floating points are truncated to, I think, 15 or 16 decimal digits. Now, if we want to print, let me show you something interesting. If we want to print 7 times 0. That remainder value and see what we get, we would get 3.0. So we now know 3 is when 10 was divided by 7, the remainder was 3, and that's the decimal value for that remainder. What this means is 7 plus 1, 7 times 1 plus 3 will give us 10, a value of a. In other words, when we do 10 by 7, we get the result 1 with the remainder 3. So in Python, it's easier to find this quotient and the remainder with the modulo operation and the floor divider operator. So let me show you what I mean by that. So let me get rid of this print statement and then combine this two print statement to say something like this. Here I will be printing y value and then the type of y in the same line. And let's say I want to define quotient as a um, floor division with b, and then another variable, and that would be a modulo b. And then I want to do something similar with two different print statements, and in each case I would be printing quotient and the remainder to show you what I meant earlier. And when I run this, I would get 3 lines of print statements. The first would be for y, what we got here, and then the second would be when we do this operation, that the result of this operation, and then the third would be the modulo operation or the result of that. So let's run. This is obviously the result that we saw earlier, and then so this basically the 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 floor division basically breaks down the division operation and just gives us the output 1 here. So when we divide 10 by 7, it's the 7 times 1 plus 3. So that 1 is what we are seeing here, and it's integer type. And then with this remainder modulo operation, it gives the remainder on what happened to the remaining portion when we divided 10 by 7. So in this case, 7 plus 3 is 10. So we are getting 3 as the remainder. So that's what the modulo operation does. It gives us the remainder of a division operation. and that's also an integer value type. So if we go back to our types of operator chart, we just did arithmetic operations with all 7 types of our operations and combinations of those. Next, I want to go is switch over to the far right side, the bitwise operators. I'm not going to go through all different types here. I'm just going to show you the concept because that is important when we go back to assignment operators, and I'll show you later what I meant here. Bitwise operators act on operands as if they were strings of binary digits. If our project needs or uses binary numbers, this is what we will use. Bitwise operators perform bit by bit operations. Let's look at some examples. So let's get rid of all of this. I'll type print y. I'll keep the print y. For this, we will do a, let's say a equals to 10 and b equals to another easier number to follow. If we were to look at 8 bits of binary numbers to represent 10, that would be something like 0000, 1010. And similarly for 4, we could do that by representations like, so it would be 0100. So in binary, 1010 means 10, and 0100 in binary means a decimal or um, number 4. And for binary operations, we do, let's say we go with the first example, first type of binary operator, ampersand. So A ampersand B would do bitwise and of these each of the bits in these A and B variables. So it looks 0 and 0 bit by bit. So for every index, it goes one by one and finds the ampersand operation. Um, so it's basically looking for um, wherever there is common um, in each index, wherever there is common one. So both the index has to have 1 in each of these 2 numbers. So basically, if here was 1, it would flag true for that position, and therefore 1 value for that position. But since it is 1 and 0, it would not flag 1 and it still remain with value 0. Similarly, here is 0, here is 1. That would still end up with a 0. So let's see that result. And when we do bitwise operation ampersand here, all the value will end up 0. So that means binary, all binary 0 means a value of 0 basically. Let's try with another operation here. Instead of ampersand, we would do or. So in this case, I'm looking for bitwise operation or. So if any one of the position has 1 in either one of the numbers, I would end up with a 1 for that position. So these all have 4, so I would end up with 0 for those. Here is 1, so I would that would flag a 1 for that position. This would flag a 1 for that position. So I would end up with 1, 1, 1, and 0, and that basically means a 14 when we output that on the pie chart. So if we go back to our chart, we did the ampersand bitwise operation and the OR operation. This one means XOR or exclusive OR, bitwise not, bitwise left shift and right shift operations. They all, if you get a concept or if you grasp the concept of how to work with one of them, you get all of them. So basically, this is where I would stop for this video on or regarding bitwise operations, and then move on to assignment operation because that is more important for a basic programmer at this level. Assignment operators are used in Python to assign values to variables. You must have noticed that we have already been using the equal to assignment operator. So that one should not be new here. But if you look at the rest of the assignment operators, they are built upon the equal to operator. Basically, they are compounded with either arithmetic operators or the bitwise operators. So once you understand arithmetic operator as well as how one of those compound assignment operators work, the rest is easy as they all work the same. For this, I want to go back to our tried and trusted values that we used earlier. So for example, I want to bring back a equals to 4 and b equals to 2, two integer values. Y would be 6, also an integer value. So let's print that again and just confirm. Um, Often we are interested in, instead of always assigning new variable when we add, let's say we want to add a plus b back to the variable a, and we want to print a instead of y, print a here and see what happens. There's no error here because it's a valid operation. We are just adding a and b and then reassigning the value to back to a. So in this case, 4 plus 2 is 6. We are assigning that 6 value back into the variable a. So instead of b, let's go one more. Let's make this more interesting. And instead of saying a variable b, we want to add variable 5 to a and then assign that to a. So we would get 9 without error. And this concept is important because often in programming we want to have a counter, and at certain interval or iteration we want to keep incrementing or decrementing that counter with certain value. For example, counter we would usually start with a 0, and after every iteration we would add a counter or 1 to that counter. So counter equals to 1, counter equals to 2, and that similar type. Um, if we want to do another operation after this first printout, this is what I meant here. So here we are calculating a plus 5, which was at the beginning a is 4. We are adding 5 and reassigning it to a, and then we are doing that same operation again here. Um, so we're repeating this bit of code. This is typically used or done using a for loop or sort of things, but I'm just showing you here for the sake of this demo. So first we add 5 to 4 and reassign that to a, and a becomes 9. And then again here, a was 9, or at this point a is 9, and we're adding 5 to that and reassigning back that 14 value to 9, or a. So when we print a at this point, it would print 14, and the type throughout this operation are still integer value. But where compound operator comes into play is, instead of saying a equals to a plus 5, there's another way to do it. So let's get rid of this, go back to our, so here I would say a plus equals 5. And that is the same as previous statement where we said a equals to a plus 5. Let me add a comment here so you know what I meant. A equals to a plus 5 and a plus equals to 5 are basically the same. So it should give us 9, which is 4 plus 5. So we could, instead of plus 5, we could do minus 5 and do 4. A equals to 4 minus 5 in this case. So it would give us minus 1. We are not limited to plus and minus. We can basically use all the arithmetic operators and get similar results accordingly. It works with division and all kind of stuff. So this operation is basically same as saying a equals to a divided by 5, which is 4 divided by 5. And when we divide 4 by 5, we get 0.8. So those are our assignment operators. I'm not going to go through each one of these and show you here in this video. You can play around with those and see what you get. If you have any questions, you can put them in a comment and I'll try to answer them as soon as possible. So that's it for this video, guys. I hope after this video, you have a better understanding of how operators work and how we can use operators and different data types to do mathematical operations and other simple operations. Just to recap, today's video we talked about various types of operations in Python, and then dived into arithmetic, bitwise, and assignment operators with some simple mathematical examples. In the next video, I would like to talk about the remaining operators, comparison, logical, identity, and membership operations. Hope you like the video. Please don't forget to like, share, and subscribe. Add your comments. Also hit that bell button if you want to get notifications on contents like this when they come out. Until next time, thank you.